Hey guys, this is video 1 on statistics and the normal model, and your goal for this video is to figure out the statistics and percentages for the normal model. Well, what is the normal model? That's what we're going to figure out today. So, statistics, let's get some background. Mean, everyone should know the mean. It's actually in your calculator as X bar. You're going to see that at some point in the future. And really, all you're doing is adding all of the numbers up and dividing by how many numbers there are. So add all numbers. No, this is not a hashtag, it means number. And divide by the total amount of numbers. Okay? Now let's look at median. So if we are trying to figure out the median, we know that from 11.6, so when we were talking about analyzing our data, that when the numbers are in order, it's the middle number. I don't think we really had any examples where it wasn't the middle number. If you have two different middle numbers, you're just going to add them up and divide them by 2. Okay, and mode, the number one thing you should think of when you see mode is most. So you're looking for the one that occurs the most often. You can have more than one. That's when we called that bimodal. Thinking back to socks, we could look at the range, or the statistics that measure spread. And that would be range, which we talked about a little bit, and that's just your highest value minus your lowest value. And standard deviation. Now this is a new word. You're going to be hearing it a lot in this chapter, and this is actually 11.7. So if you want to write that at the top of your paper, 11.7 in the textbook. So standard deviation. That's just how widely data varies or spreads out. Okay, so now that we have some basic understanding of the vocab, let's move on to actually looking at some of this data. So we have a whole bunch of data in our blocks here. And in these blocks, I'm going to use my calculator. So I'm going to grab my calculator and get all of this information from the calculator, as much as possible anyway. So I got my calculator, and I am going to follow the directions over here. So enter data into L1. So first, turn your calculator on. Always the first step. Now hit Stat, Edit, and I already put in the data, but what you want to do, you can pause the video if you need to, take your calculator, put in your data, so all the way down, and we're only caring about L1. Okay, once the data is in there, follow step 2. So Stat, we're moving over to Calc, and we're doing the one variable stats. You should have done this last class as well. I'm just going to hit enter to get my data. And at first, this looked really confusing. We have a whole bunch of different things in here that we've never seen before. Well, now that we know that mean is X bar, right here is our mean. So I can write that down. I know it's a little hard to see on my calculator, but 6.71. And that was my X bar. Now we need to look at our median, and that's in your calculator as well. You just have to scroll down. MED stands for median, so 7.5 is my median. And that looks like MED, med. Mode, that's something you can't get from the calculator. You actually have to look at your data. So our mode, I see 3/8, but I also see 3 9s. So this is something bimodal. So 8, 9, and this is bimodal. Remember, you can't get that from the calculator. You actually have to figure that out on your own. SD stands for your standard deviation, so that's something that we just started talking about. Standard deviation, there's a couple different ways of looking at standard deviation, but this little squiggly line here, so it looks, it's actually called a sigma. So sigma x is your standard deviation, and that stands for the population standard deviation. So we have 2.71, and that looks like sigma x. Finally, the range. Now, it doesn't give you the range in the calculator, but it does tell you your maximum value, which you should know just by looking at it, and your minimum value. So 12 minus 2, because that's my max, 2 is my min, and everyone should know that's 10. Okay? So make sure you write down somewhere that sigma x is your population standard deviation. So that's just an example of some data that you could use to come up with all of those numbers. We have talked a little bit about types of distributions when we were talking about SOCs. So how spread out something is, that's our spread, the last S in SOCs. So we have something that's symmetric. I know my class we talked about how symmetric distribution looks kind of like the bell curve. We have right skewed and left skewed. And a good way to think about that is, well, there's two different ways. You could look at where the tail is. So over here's my tail. So I know that my tail is on the right, it's right skewed. Tail is on the left, left skewed. And ultimately, you're just going to say it's the opposite of where all of your data is. So opposite of where the data leans. Whichever way helps you remember it, that's the way you're going to go. Okay, so now that we've looked at the types of distributions, when data is symmetric or centered around the middle, so that's this first one, everything's centered right in the center here, with no skew left or right, we call it a normal distribution, which is kind of the whole point of this set of notes. Remember, our objective, we were to figure out what the normal model is, and right here, this is my normal model, the symmetric distribution. And again, like I said, we call it a bell curve. There's a whole bunch of different explanations of when you would see normal distributions. I already mentioned grades. SAT scores go along with that. We also have, you can talk about weight or height. There's also your IQ and batting averages. Body temperature. But honestly, the list goes on and on. There's so many different examples of metric distribution, normal distribution, or a bell curve. So now that we have a little bit of background, you're going to actually watch another video that you have on the back of your paper. And that video is going to explain a little bit more what a standard deviation is. Okay?